In our solar system, there is one planet that does not spin like the others. It lies almost on its side, rolling around the sun like a gigantic ball. Because of this bizarre orientation, a single season on this world can last more than 20 years. It also possesses a magnetic field so distorted that we still cannot fully explain it. Beneath its cold blue clouds, immense pressures may create storms that rain diamonds from the sky. In the entire history of space exploration, humanity has visited this world only once. For decades, Uranus was considered the most boring planet in the solar system. But the more we study it, the stranger it becomes. It may be hiding the scars of a cosmic catastrophe that occurred billions of years ago, an event that completely changed the fate of an entire world. This is the story of Uranus, the strangest planet we have ever known. In 1986, after traveling through space for nearly a decade, Voyager 2 became the only spacecraft ever to visit Uranus. But the first images it sent back were disappointing. Uranus had none of Saturn's spectacular rings, none of Jupiter's famous storms, and offered none of the hope for life that made Mars so fascinating. The camera revealed little more than a nearly featureless sphere, lacking any striking details, earning it the nickname the boring planet. But honestly, Uranus is far from boring. We've just barely scratched the surface. At a distance of nearly 3 billion kilometers from the Sun, sunlight is incredibly weak. The observational technology of the time simply could not penetrate its blue cloud layers. Only years later, with the help of more advanced telescopes, did an entirely different world begin to emerge. While most planets spin like coins swirling on a table, Uranus alone tilts completely, orbiting the Sun like a rolling wheel. The consequences are almost beyond imagination. Uranus takes 84 Earth years to complete a single orbit around the Sun. During part of that journey, one of its poles remains in continuous daylight for about 21 years, while the opposite pole is plunged into darkness for just as long. So, what could possibly have happened to tip an entire planet onto its side? Tilting a planet 14 times the mass of Earth seems almost impossible. But billions years ago, our solar system was a chaotic place, filled with constant collisions. Looking at the leftover clues, scientists have proposed a dramatic theory. Perhaps an object the size of Earth slammed directly into Uranus. It was a catastrophe of cosmic proportions. The impact didn't destroy the planet, but it knocked its axis of rotation to nearly 98 degrees. It seemed like the perfect explanation, but supercomputer simulations showed otherwise. Such a violent crash should have stripped Uranus of much more material, leaving behind a very different system of moons than what we see today. Because of this, a new hypothesis emerged. Maybe Uranus didn't go down in a single blow. Instead, it was struck multiple times by smaller objects. Each impact tilted the planet just a little bit. But after millions of years, those consecutive nudges slowly pushed it entirely on its side. To this day, neither scenario has been proven. But if that disaster did happen, it left a lasting scar. A bizarre magnetic field unlike any other planet in the solar system. Back in 1986, when Voyager 2 first measured Uranus's magnetic field, scientists thought their instruments were glitching. The data coming back just seemed too crazy to be true. On most planets, the magnetic field lines up pretty closely with the axis of rotation. But Uranus completely ignores that rule. Its magnetic axis is tilted by about 59 degrees, and it's shifted thousands of kilometers away from the planet's actual center. The rotation of Uranus causes its entire magnetic field to twist and distort, creating one of the most chaotic magnetic environments ever seen. Unlike Earth, where the magnetic field comes from a solid core, Uranus's field is generated by a messy, swirling ocean of super-pressurized water and ammonia. It's a giant, churning cosmic blender, cooking up a magnetic storm unlike anything else in the universe. But if you think that's the weirdest thing about Uranus, beneath its blue clouds lies a phenomenon that sounds straight out of science fiction. Deep down there, it might actually be raining diamonds. Imagine plunging into Uranus. As you dive deeper, the blue sky fades away. The pressure rises relentlessly, far surpassing anything on Earth. At these depths, matter begins to behave in bizarre ways. Uranus's signature blue hue comes from methane in its atmosphere. But this very gas might fuel an incredible phenomenon. Under immense pressure and extreme heat, methane molecules break apart. Hydrogen separates, while carbon atoms are squeezed so tightly together that they transform into diamonds. These crystals likely form continuously, raining down into the deeper layers under the pull of gravity. In near absolute darkness, an endless shower of precious stones has probably been falling for billions of years. Amazingly, this isn't just science fiction. Using powerful laser pulses, scientists have recreated the conditions inside ice giants. Of course, no spacecraft has ever witnessed this firsthand. We cannot peer through thousands of kilometers of dense gas and matter. Yet, experimental evidence makes this hypothesis increasingly compelling. Even if these diamond rains are real, no human machine today could ever reach them. The crushing pressure would obliterate any probe long before it could catch a glimpse of the first diamond. Ironically, a world capable of forging diamonds within its depths holds another chilling record. It is the coldest planet in the solar system. Based solely on distance from the Sun, most people would assume Neptune is the coldest planet. It lies about 1.6 billion kilometers farther out than Uranus and receives much less sunlight. Yet, nature offers a completely different answer. Temperatures in Uranus's atmosphere can drop to around -224 degrees Celsius, the lowest ever recorded in the entire solar system. So, where did Uranus's energy go? Other gas giants act like massive radiators, emitting more heat from their interiors than they receive from the Sun. Uranus alone remains nearly silent. It radiates very little heat, as if its internal fire cooled and died billions of years ago. Scientists have yet to agree on an explanation. Some suggest a cataclysmic collision bled off most of the planet's internal heat. Others believe the heat is still there, trapped beneath layers of matter we don't yet understand. Remarkably, all of these theories are built on an incredibly scarce amount of data, and that, perhaps, is the greatest mystery of Uranus. After everything that has been said, the most surprising truth is actually very simple. Humans have barely explored Uranus. In history, only Voyager 2 has visited this planet, back in 1986. It did not enter orbit, it did not land, and it did not stay to study. After just a few hours of close-up observation, the spacecraft continued its journey into deep space. It is like trying to understand Earth while only being allowed to sit on a plane flying by for a few hours before leaving. You would see clouds, oceans, and mountains, but it would be almost impossible to understand how the planet actually works. That is exactly what we have done with Uranus. Every time our observation technology improves, Uranus shows that what we once believed might be wrong. Far from being tedious, it features colossal storms, ultra-fast-moving clouds, and incredibly complex seasonal changes. We used to think Uranus was boring simply because we looked at it too hastily. Because of this, returning to Uranus is being considered one of the top priorities for future missions. An orbiter operating for several years could help answer questions that have persisted for decades. And who knows, the planet once deemed the most tedious might just be one of the most fascinating masterpieces nature has ever created.